Hi, I'm Dave Shanley, and this video is a quick tutorial to help you understand the basic mechanics of how PubSub works and how you can call an asynchronous API from a browser using JavaScript, STOMP, and WebSockets. If you're not familiar with STOMP, it stands for Simple Text-Oriented Messaging Protocol. It's a straightforward but stable protocol that makes talking to event-based or message-based APIs an absolute breeze. Now, you won't have to learn how STOMP works to use this tutorial. We're bringing in a library that encapsulates the protocol. We're going to use Transport for this tutorial. It's an asynchronous API framework implemented in multiple languages, and it supports STOMP out of the box. Okay, let's get cracking. Our application is going to be a simple stock ticker. We'll type in a stock symbol and request it from the stock ticker service that's running over at transport-bus.io and is running via WebSocket. The service will respond with details about the latest closing price for that stock symbol, and our UI will render it out. Let's keep it simple and create a new React application using create-react-app, and we'll name it stock-ticker. Now change directory into the stock-ticker folder directory, whatever, and now you can install transport.js. Now, Transport only has one dependency. It's a significant dependency and it's RxJS. So let's install it. Yarn add RxJS. Now, let's install Transport. Yarn add @vmw/transport. Most likely, some warnings from Yarn mention Transport needs TypeScript as a dependency. Now you could ignore this because Transport is actually written in TypeScript, but it doesn't need it for non-TypeScript applications. In fact, it doesn't need it at all. So to stop the warnings, you can add TypeScript, but as I said, it's not required. Let's kick off by creating a new file called transport.js. Let's import the bus util from Transport. Here we will create a custom hook called useTransport. It's a simple way for components to access the singleton event bus. Next, we import busutil and log level from Transport into our index.js file. We will use them to boot the event bus properly and set the logging level correctly. We're using the boot bus with options function on busutil. It boots the bus and sets a few common options that we need, allowing us to set the logging level to debug, print out the boot banner, and use dark mode colors. Let's head over to app.js. Now, create React apps, the scripts, will generate some example code here that we don't need. So let's go ahead and clear it out. Let's import useState and useEffect hooks from React. Now, let's use our custom hook, useTransport, to get a reference to our event bus. We want to track if we're connected, so let's create a new state variable called connected and set it to false. Fabric is just a shortcut to bus.fabric. Next, we hook into the component lifecycle with useEffect. If connected is false, which it is to start with by default, we're going to want to connect to our broker that's actually got our stock ticker service running on it. So let's use fabric.connect and provide two closures. Now, Transport uses a pattern of success and failure handlers for all operations, and in this case, connected handler and disconnected handler. In our connected handler, we're going to log out to the console that we've connected. I know, it's very creative. And we also do the same in our disconnected handler. Then we can update our component by setting our connected state to true when we're connected, and the opposite by setting it to false when we're disconnected. Next, we set connect to transport-bus.io on port 443 using the WebSocket endpoint /WS. We enable TLS, and then we define the topic and queue endpoints for the broker. Now we can put in a new page title and get cracking on our stock ticker component. Create a new file called stockticker.js and then import the useState and useEffect hooks from React. Next, import our useTransport custom hook, as well as general util from transport. Now we can create our stock ticker component. First, we define the state that we need to capture, starting with the stock symbol lookup variable that we want to capture in the UI. Then we want to capture the last closing price of the result that we get back. Next, we want to capture when the closing price was last refreshed, essentially when it was last fetched from the source. Let me fix the stock lookup to use Google as the default symbol lookup. Now, let's capture the stock symbol the service tells us that it's reporting. Then we want to capture any errors that the service may throw. Last, we want to remember if we've subscribed or not. Now we can create a reference to our bus using our custom hook. I want to take a second to explain the essentials of transport and how it works so that the next bit makes sense. Transport is an application event bus that operates as a singleton inside an application. Components or actors can message each other asynchronously using the bus without needing to have a reference to each other. The bus allows the creation of universally available channels that all components in the application have access to. A key benefit to this design is that it makes it easy to build decoupled, event-driven application architectures. A feature of Transport for Go is that it has the ability to bridge instances together without needing a third-party message broker. It has a micro broker built in. Transport can connect over TCP or WebSocket, and it uses STOMP as the wire protocol. In fact, it can connect to any message broker out of the box that supports STOMP. There is a concept of marking channels as galactic in Transport. And this essentially means that an application bus channel is mapped to a broker destination. Under the hood, Transport automatically subscribes to that broker destination and then relays any inbound messages to that local application event bus channel. Marking channels as local will unsubscribe from the broker destination. Okay, I'm sorry. Let's get back to the tutorial. Then we define the channel that the service is operating on. In this case, it's stock-ticker-service. Next, we create a connection string using the getFabricConnectionString method. This is required to subscribe to our broker destination. Now, Transport can connect to multiple brokers, so the connection string identifies which broker that we actually want to connect to. We use the transport-bus.io host, port 443, and use the /WS WebSocket endpoint. Next, we implement useEffect and subscribe to our broker destination. If we haven't subscribed yet, which we haven't to begin with, we use the mark channel as galactic method, and it automatically subscribes to the client destination on that broker. We're marking this channel as private, which means it'll use a queue and be a one-to-one conversation. We set our subscribe state to true. Then we can return a function that will use the mark channel as local method to unsubscribe from the destination when the component is unmounted. Let's not forget to pass our variables to use effect, so we don't get stuck in an infinite loop. Next, let's implement the handle symbol change function that will fire when the component form input changes. We set the stock lookup state using our event's target.value property. Now we can define our request stock function. Let's create a new request via the generateFabricRequest method. If we take a look at the AsyncAPI contract for this service and look at the publish command, and then we have a look at the example, we can see that the payload of our message is just a simple object that contains a single property named symbol. Now, if we expand the definition of the message, looking at the payload, we can see that object definition using the symbol property. It's very straightforward. We should note that the operation ID is ticker_price_update_stream. And operation IDs are what transport calls commands. Let's get back to our code. The command we want to use is ticker_price_update_stream. And the payload we want to send is that simple object with that key symbol, and we'll use the stock lookup state that we've already captured. Now we can define the logic that will send our request over the bus to our stock ticker service that is listening at transport-bus.io on the channel stock-ticker-service. We use the request once method to send our request, and it returns a handler object that we then call handle on. I know, very creative. Our handle accepts two closures. The first is a success response, and the second is a failure handler. If there is a payload with a response, we know that the service has actually responded with something that we can use. So let's update our component state with the values that have been provided by our service response. The close price, last refreshed, and symbol states are all set. So now we can set up any error if there's no payload available at all. If anything goes wrong, the error handler will fire and pass an error object that we can then capture as well. Last, we return our component JSX. Let's create a ticker symbol label for our form input. Then we can create a text input whose value we bind to our stock lookup state. Every time the value changes, we want to pass the event to our handle symbol change function. Next, a button to trigger our request stock function. And last, we add a couple of placeholders for our stock result and our stock error components. The stock error component only renders if the props contain an error message property. We need to return whatever message the service has sent back, so let's render that out as simply as possible. Lastly, we define our stock result component. Let's limit the price value to 2 decimal points to make it simpler to read. Then we can also extract the last refreshed and symbol properties. If they're all set, we can render a simple stock result. all that's left to do is go back and add our new stock error and stock result components to our stock ticker component. We set the close price, the symbol, and the last refresh time props. We need to add the stock ticker component to our React app to finish. Let's fix this typo here so our application compiles properly. Let's run our application. In our terminal window, we use npm start, and our application should appear. I know it looks crap, but that's easy to fix later. We're only interested in the mechanics of the pub/sub call for this tutorial. If we press the button, we should see our stock result. Type in another stock symbol, and we get a different result. Looking at the developer tools and our WebSocket connections, we can see the STOMP conversation happening over the wire. Subscribing, publishing, listening, and unsubscribing. If we look at the console, we can see that transport is taking care of quite a bit of the mechanics. And that's it. To learn more, head over to transport-bus.io or GitHub. The links are in the description. If you enjoyed this video, hit subscribe, leave a comment, and then head over to quobix.com for more adventures in code. Until next time, see ya.